So I think we're getting close to the time mark, so let's start out because I have an hour of content that's going to be hopefully fitting the next 60 minutes. And I'm going to talk about securing your .NET application software supply chain. I'm going to extend a bit of the story that Laura told this morning during a keynote. I was really happy to see that kind of a keynote happening at a developer conference because, of course, being a security guy, I know it's important. So today we're going to dig into a bit more of this. First, so it's polite to introduce yourself, so let me do that. So I'm Niels Tanis. You should probably notice I'm not from here, I'm from the Netherlands, Europe. I traveled in for NDC Sydney, really happy to be here. And I'm a security researcher within Verico, which means I have a background in development, software development, and I've done some pen testing, ethical hacking as well. Right now, what I do with Verico is I combine all that into my current role where I focus on .NET static analysis. That's all you can get from me, like from Verico, which I'm going to mention right now. There's going to be one more slide that includes the company, but now we're going to focus on supply chain because that's the problem that we're going to talk about today. So if we look at the way that software development has changed over, let's say, the last 20 years, it changed drastically, right? Pretty significantly. Myself, I started out developing with the first .NET framework, like 1.0, early 2000s. And if you then see the way that we take software, big monolithic application that I wrote for a customer and go back to the IT person saying like, hey, install this on your machine and make sure it's available for everybody within the company. That was the job you did, right? And there was nothing more, nothing less. If we compare it to the way that we develop software right now, it's more continuously, right? Cloud native, microservices, like deployed a couple of times a day, maybe even. We're all not Facebook, but there's maybe some more automation in place. And that whole chain, that whole process has become a lot more complex. And you can also imagine that it also involves a lot more risks if we look at it from that perspective. So with that said, I'm going to define the agenda of the thing that we're going to talk about. First, I want to briefly have a shared view on what I think is a supply chain, or at least like what's the supply chain we're going to take as a default and walk through some of the problems we run into. Then we're going to focus on securing each of the areas related to developer and source, third-party libraries, build and release. And then at the end, I'm going to conclude, and there will be a Q&A. But I think if you want a question being asked straight away, let's do it. Make sure we need to make sure you have a microphone, that it gets recorded as well for the people who are watching the video or the stream. I don't mind that. People who have seen me do this talk in the past, because I've done a supply chain talk in 2020 online for NDC Sydney as well. Concepts have not changed, right? So you might see some familiar stuff, but the industry has made some really good steps into a direction that helps us out securing our supply chain, and you're going to see a lot more demos. So don't worry about that. If you have seen the other one, yes, you're going to recognize stuff, but there's a lot of goodness in this as well in the new thing. So evolution of software. This is a patterns and practices picture that I took a while ago. It illustrates the gray box, which is a monolithic application that contains it all, that we deploy somewhere that has been run. Then the one there below is maybe, let's say, scaling off that, or maybe what we did at some point, like a load balancer. We had a web front end and a SOAP XML based back end, right? With web services running on .NET to scale it out. And then on the right hand side, you maybe see something that's more applicable on what we do right now. Let's say smaller logical containers that we roll out on a cloud infrastructure like Azure or AWS or Google. And it has become more granular. And with all that, in order to deploy our software, to build our software, to do our things, we have a lot more moving parts involved. And from source to something that we deploy is something that we can see as a supply chain. And one analogy I've used all the way is something that's, of course, familiar. That's the automotive industry. How is a car being built? At some point in the factory, there's a lump of steel that comes in. Customer has ordered the car, and throughout the factory steps, it will get value added, right? Parts are being added to that car. A German car manufacturer will put an average of 10,000 parts on a car, which originate from 3,700-ish different suppliers. So different manufacturers that are responsible for parts that are being put on a car, right? And from the beginning to the end, when it rolls off the factory, it's the supply chain of that car. And for software, we can have a similar definition. We can say a developer writes source, developer uses third-party libraries, which of course can have a lot of consequences, which we're going to see later on. But also, developer use libraries that are already there. I'm a lazy developer myself as well, right? Why would you reinvent the wheel if stuff's already there? It makes sense to just take it. Of course, source then needs to be built. Let's say you use GitHub Actions. In this case, I'm illustrating it with the GitHub Actions icon, but it literally can be any build system, right? It doesn't matter if it's GitLab or if you're running on OpenShift. It's all the same. Hopefully, you do some QA testing on your software before you roll out security, right? Integrated from the beginning. It's a good idea as well. And then at some point there is an artifact that will be deployed, which can be a package that you release to, let's say, NuGet, or you have a Docker image that you put on a Kubernetes cluster that runs in production, and then it gets rolled out, right? So that's almost similar, like starting out with code that's being written by a developer and something that is deployed in production or is released for customers. And what could possibly go wrong with supply chains? And I think the most clear example is something that happened to SolarWinds. They had one of their build servers compromised, which eventually turned into a situation where their software was being equipped with additional malware inside of it. There are questions like who's behind it, like what happened, why. There's a lot of stuff you can find on it. That's not what I'm going to talk about, but it's more like if you look at this from this perspective, the package was authentic because it was even signed. It was built by the build server that the company always used to release the package, right? So you could not see it from the outside. You needed to look into it in order to distinguish that there was logic inside that did not make sense for that component, and that was the malware that was put in. There are some really good articles. One is from Microsoft on how they've done it, and this is the one from CrowdStrike. If you want to read through it and want to know more about what happened here, those are the go-to articles. I'm referring to sources I'm using. I have a slides and notes version at the end in my GitHub repo. I also have a couple of demos, so you can find it there, and in those notes you will find the links to these articles as well. And funny thing is that SolarWinds have solved this problem with their supply chain, which you're going to see at the end of the talk. So we're going to walk through what's happening. And this is a cartoon I've used literally in every presentation I gave over the last year, or at least 2 years, I think. So XKADC, you're probably familiar with the Bobby drop tables. That's the one you normally see with SQL injection. This is the one that's all about all modern digital infrastructure. And you can replace it with all modern, let's say, application architecture. And somewhere underneath, there's a project that some random person in Nebraska has been thanklessly maintaining since 2003. Right? So we build software on top of libraries that are there and that we just sometimes take for granted that they are there. But can you imagine that one of those pieces is taken out or is compromised? It means that your supply chain is compromised. So one library that you're consuming, if something bad happens, then your supply chain is compromised as well. So that's the problem space. And let's first focus on what we need to do as developers, right? If we write software, we need to do something with source code. And if we work with a Git-based system, we're storing stuff in it. In order to have access to a Git system, we need to have credentials. And what happens with credentials? Credentials get stolen. So in this case, this is an example of 2019, where the canonical GitHub account credentials were stolen. I think it was just an ordinary credential theft, like username, password. But canonical are the people behind Ubuntu. And they had access to repos. I think some bogus projects were created. Nothing really bad happened, I believe. But you can imagine that what type of leverage somebody would have if you have access to those repos. Because if you see my demos later on, I use build servers that are based on Ubuntu. So that's already a part of the chain that gets compromised. And in this case, that was the problem. What can we do? And this is also something that Laura mentioned this morning, multi-factor authentication, right? If you have username and password, that's not enough. We should be more, let's say, aware of the fact that this can help us out doing a better job. If you then look at the stuff that happened to Uber I think weeks ago, there was multi-factor authentication. It was more about multi-factor authentication fatigue because the administrators were like bothered too much with that screen, like, hey, you need to approve that I'm logging into, that it solely was bypassed and somebody had credentials, and that was the reason like why the person got in, I believe. Right? So we need to use it, but I don't see any reason why you should not use MFA with your accounts that you value most. And the same counts for having access to source repos. What else can we do with Git? There's also a concept called Git commit signing. And Git commit signing takes a public-private key pair, GPG key pair, right? which is, of course, if I sign something with a private key I keep close to myself and that I own, others can validate that based on the public key I'm sharing across. And that's exactly, in a nutshell, and there's probably a lot of better talks on crypto. I'm not doing that, but this is in basic the concept that you're doing. And with Git commit signing, I put my public key in my GitHub account, and then I get the nicely verified badge after each check-in that I do. And what's this worth? It's useless because it's just a badge that gets added to the change set if you look into it. But it at least can give you some kind of guarantee, like somebody committed this, had access to my account, so my credentials, and also should have got access to that key to sign it. So that's the additional factor. So if there is a git commit done with no signing involved, then that might be a flag like, hey, we need to investigate. What happened here? What did you do, Niels? Did you commit something without signing it? Oh, I don't know. So that's the thing, right? It can be an indicator of something happening. What else can happen with Git and with people who are involved? People can do social engineering. And this was a study that was done by the University of Minnesota where 2 people got involved with the Linux kernel. And they just became contributors to one of the projects. And then he eventually turned their back and became malicious, between quotes, just as a test to show if you can convince people, then you can still get your guts into the Linux kernel and get stuff inside of that, right? So some of them were not happy that this was done, but it shows that this is still a possibility. So looking at source code, looking at how we interact with it with credentials, what else do we need if we develop? An IDE. And this is a dependency graph, which you also saw this morning at Laura's talk, which is the newer version, I believe. But VS Code is one I use quite a lot, and I like it because it's open. I can get extensions for every language that I need to dig into. That's cool. But it runs on Electron. This is a dependency graph of the Electron NPM package that's being used inside your thing. And you see that there's a transitive list, right? You don't need to know exactly what's inside, but you can see the complexity and how deep it is and how many things you get. Which means that there's 82 dependencies. Those 82 dependencies are being maintained by 110 maintainers. There are people who are responsible for those packages that will release it, that will work on it. And there's even multiplied by 10 amount of contributors on those packages. So those are people who touch code that end up in Electron, that's been used by Visual Studio Code, that also ends up in Slack, that ends up in Teams, because it's all Electron based, right? You can imagine what the effect would be if somebody got in there and did some stuff. So that's something just to be aware of, that this is a big thing, because also IDEs itself, vulnerabilities are found, right? And this is one that happened in May of this year. VS Code had a remote code execution vulnerability, which luckily was nicely responsibly disclosed by somebody with Microsoft. And if you do it in the right way, you can even make money out of it. And that's a cool thing. But stuff happens, right? And what else can happen? Because as I said, software has become more complex. VS Code itself has integration scripts that it runs in order to build VS Code before it releases. So one security researcher figured out that some fields that you use inside of a pull request gets parsed in such a way that it resulted in a code execution, allowing him to have access to the source code of VS Code and commit changes. And that's exactly what he did. He just committed a bogus commit, say to Microsoft Security Response, this is what I did. He got money for it because he disclosed it. But this is also like an example of showing there is a small piece in the supply chain of VS Code that got compromised, allowing somebody to alter it, right? And then, of course, we write our code based on that IDE. And yeah, it's good to be aware of the fact you need to upload those and keep an eye out what's happening. So, developer interaction, source, IDEs, what's next? As I said, as a developer, and I do it myself as well, we rely a lot on third-party libraries that we get from NuGet, NPM, or we get Docker images like layers we build up in order to get our production images ready, for example. And what happens with third-party libraries? So we, with Veracode, this is the only time I'm going to mention Veracode, we have a state of software security report that we publish each year, where we talk about some of the metrics we see in the field, and we explain like what we see. And in the edition of last year, we saw that almost 80% of the time, developers never update third-party libraries in their projects, right? So they probably do a periodically scan of their app, and we can see like they never touch it. That's quite disturbing, I guess, because what happens with libraries, the libraries have security problems found. And in this case, it's one that's related to .NET, and it resulted in code execution. This was a pretty big one. Right, so that happens. We need to update libraries. There's more to libraries, which we're going to touch later on, but you need to update. And what else can happen with libraries? Libraries can have malicious stuff added, and this is something that happened to UA Parser a year ago, almost a year ago, which is a library that parses user agent strings. Somebody added some cryptocurrency targeting, like he wants to steal cryptocurrencies from somebody. That's the stuff he put in, and this was all done based on some maintainers' credentials that got stolen. But NPM itself, of course, is a really tightly coupled ecosystem. If you look at dependencies and graphs you can create out of it. There was another instance of event stream a couple of years ago, which was pretty significant, like millions of downloads a day of a package. And if you grab hold of it, and if you compromise it, then you have every package that consumes it, or like every app that consumes that package, is compromised as well, right? GitHub, of course, and Microsoft own NPM. They bought it last year, I believe, right? And they made sure that they do the better job by making sure that maintainers have multi-factor authentication turned on. And they enforce that. So that's a cool thing. That helps out making that ecosystem more secure. What else happens with dependencies? There's a concept called dependency confusion. And imagine the following situation. You have NuGet packages that you consume that belong to your internal organization, that you run on a private feed for your organization, right? Which makes sense because it allows you to do some consolidated development all in the same way, right? That's the reason probably. What happens if somebody, and that package is identified by a name, so if you do a .NET CLI, you say .NET add package, you add the name, that name is the package that will be fetched from that private repo. What happens if somebody publishes a package publicly with the same name? Then the package manager might be confused because it doesn't know which one to get. And that's exactly what this concept is about. And it's applicable on a lot of different apps and ecosystems. And this person made a lot of bug bounty money out of this by just looking into different software systems that had the same issue. So that's the problem. What can we do about this? So Microsoft published a really good paper on 3 ways to mitigate risks when using private package feeds, securing your hybrid software supply chain. You can find this PDF link in the slides. And what it generally advises for NuGet is you can always try to maybe consolidate into a single private repository for all your packages, right? You can imagine that it's not possible because you might still have upstream things you want to get from the outside. Then something like Azure Artifacts might be a project that can help out, or Artifactory or some other product that does exactly the same. If your company has public packages as well, make sure you can consider to register the prefix. If you look into NuGet right now, you look at Microsoft Dot, you see that there's a mark behind it saying like, hey, this is registered one. Right? That's exactly done for this reason. So you could consider doing that. That makes sense. Or you could maybe lock in packages in your config, making sure that you only use the packages that you intend to use. Right? That's the locking down fully. So I know that this is high over, but this dependency confusion, right, that relies on packages that might be loaded from a different location, which you don't expect. If we look at third-party libraries in general, what's another thing we need to be aware of? And this is something that is also close to my heart. If you look at libraries, I'm always trying to convince people, like, please be aware that if you take something that you use, like, what's inside? What do you expect from that library? What do you expect that library to do? And it's always a list of transitive dependencies. If you add a package, you always get a whole tree for free behind it because it relies on a lot more. So tomorrow I'm doing a talk in this room at 3 about a .NET sandbox that I created that can eliminate some of these risks. So if you're interested in, I hope to see you here tomorrow again. If we then look at what we can do about this in another way, is the Open Source Security Foundation, or the OpenSSF, has published a project called Security Scorecards. And as it states, it's a security health metrics for open source. You can see it as a nutrition label for libraries. And they defined whole standards on where they would look into what the checks would be and how would it looks. For example, if you would correlate it to food, like a lot of salt, a lot of sugar in food is not a good choice, right? Maybe you should choose the alternative that's better for you. So based on security scorecards, Google has created a site called deps.dev, where they take the security scorecard definitions and like what the checks are, and they apply it to different ecosystems like NPM, Go, PyPy, Cargo, And NuGet is coming soon, but that's what they've said since the last 2 years. So I still hope it still arrives, because it's a experimental project. I hope it's going to stay, but it allows you to see stuff. So if we then take the scorecard of Electron, the library we just saw in the dependency graph, we can see it scores a 6.6 out of 10. And there are, if you look into the scorecards, there are different areas you can look into. Like, do they do any static analysis or SAST? That's not the case. So they scored 0 out of 10. Same counts for fuzzing. And if we then look at what they do for code reviews, they score an 8 out of 10, right? If a library scores a 1 out of 10, you can probably guess that it's not a good choice, right? But this is at least giving you visibility of, like, this library does this for security, so you can make better informative decisions. That's the goal of security scorecards. Pretty cool project. What else could be inside libraries, talking about intent and all the stuff, is something called .NET source generators. And they're pretty helpful, but they also can backfire the other side. So with .NET 6, I believe, for example, Razor precompilation fully moved to source generators, right? Which helps it to be more performant, and there's no initial hit if it needs to be compiled, or there's no need to precompile it, that kind of things. But what if source generators are being put inside a third-party library that is part of your project that you compile? Those are executed. And one of my colleagues, Matthias, has wrote a blog post and created a concept where he takes a source generator and allows it to inject a backdoor inside your application by just putting it inside a third-party library. What can you do about this? Pretty deliberately, you can say, I want to disable all analyzers and source generators. But that's probably not going to work, because, as I said, Razor, for example, relies on it to do its job once it compiles and once you have your application ready for production. But it would make sense to look into which projects need it and at least have some sense of that in order to make, as once again, better informative decisions at that point. So, third-party libraries. What else is important for our supply chain, and what is important for building software? And that's a concept called reproducible or deterministic builds. And what that means in a nutshell is that you should be able to get source code from a NuGet repo, let's say newtonsoft.json, compile the package and have a package that's, like, on binary level exactly the same as you want to get from NuGet. Because otherwise, how can you have the guarantee that that code that you just saw was the one that was compiled into the library? There's no guarantee that's a hard, that's a hard one to say, like, yeah, that's true, right? So reproducible builds should be able to help us out. And luckily with .NET, with Roslyn 1.1, they started out supporting some kind of determinism. And they define inputs that if you have certain inputs, then the outputs will always be deterministic the same. And there's a list, you can find a Roslyn design document about this. But it involves SDKs installed, Windows, which version are you running, that might still have influence on how a library is being admitted. So this is a hard problem. So now we're going to see if you're still with me or if you're falling asleep, because this still is the last session of the day. I'm going to look into reproducibility of .NET and .NET 6 and look into what's happening, and also want to have maybe your answer on what you think, what will be real. So what I have here is a console app, and it's as easy as it gets. Single console, write line, hello, NDC Sydney. And what if I just say .NET build app? Well, let's say I take this project, exactly the same project, and say I'm going to copy it. I'm going to say I'm going to create this folder and I'm going to do it to app2. So the content of that thing is exactly the same. If I now do a build of app and build of app2 as well, who thinks these two console apps are exactly the same? Let's check it out. See, one hand raised, that's cool that you're with me. So let's say we're gonna look into the DLL that's created. So we have app1, I say /app bin debug app DLL, net app DLL normally I would create a script for this. Maybe I should do that next time. app2, that's the other file. This is just showing some of the file stuff by doing an ls on those to see, hey, what do we see here? So file size, these are the two files, are exactly the same. What if I do a diff, right? Diff command on Mac OS X is comparing it on a binary level. It says it's different. So I have a script over here that I'm going to run right now because I'm not going to wait for it. But what it does, it grabs the strings of the binary itself and it shows us the differences. And what we see over here is there is a pointing out to a PDB file. And in this case, one PDB file comes in a different folder than the other one. And that's the reason why those files are binary, not the same. If you look at the IL, they're probably completely the same, but if we look at it on binary level, this is not the same. So what can we do in order to fix this? We can turn off the emission of, let's say, like we don't want to have any debug symbols included, and then we're good to go, which of course is not what you would do in production. But if we can get this one out, let me quickly do that, then you see that these are the same. So let's say, and now let's take the project and let's explicitly say that the debug symbols are none, so we don't have them. And if I now say .NET build app, no, let's first do the copy to app2, and let's say .NET build app, .NET build app2. And if we now do the diff, you will see that these are exactly the same, right? So by just excluding that. So this is not what you would do, but that's the reason, like in those headers, there's a difference in those PE headers that point out to the PDB file. What can we do about that? Let's get back to the presentation. So as I said, deterministic builds have been turned on by .NET as well. By default, that's cool. There's another package that is called .NET Reproducible, which is created by somebody who was part of the NuGet team, that allows you to set some configuration to help out with setting a flag called continuous integration build. Also source link, right? Making sure that your source files are being put to, let's say, this is the Git repo, these are the source files you're using. And it also embeds the PDB in such a way that it will be consistently the same. There's a second package that can help out, which is called .NET Reproducible Isolated. And what it does, it also limits where NuGet can get its package from. So you want to have control over within your source base, say like the packages can only originate from this folder, or I want to only use this registry, nothing else. That's the one you also need to include in order to limit that. And the other thing, also something that I ran into when I was talking about it with somebody from the NuGet team, is that there is a design that they are willing, like hopefully implementing somewhere in the future, but that would allow us to be reproducible with .NET packages, but also allow us to validate .NET packages by having a .NET CLI tool called .NET Validate, and say, this is the source, this is the NuGet package, does it match? I think this is pretty powerful if every developer can do it themselves to check this and to make sure that your build is reproducible. So, reproducible build. As I said, SolarWinds had their packages signed as well for authenticity. Is it a good thing to still sign software? I think it is. And signing artifacts in general definitely is a good idea. If we look at a project called Sigstore, this is from the OpenSSF Linux Foundation as well, publicly available, everybody can use this. Sigstore has the goal to become the Let's script of software signing in the same way. So everybody can request a code signing certificate. There are some people on the internet that wrote blog posts on how you can get a code signing certificate. I think it even involves sending out a paper with a photograph and a picture involved in order to show, like, hey, this is really me. And Sigstore is taking all that away. And they generate certificates. They have a whole ecosystem. I'm not going to talk about it in a lot of detail, but some of its powers lies in the transparency log, for the same reason that you can just validate if a certificate is being published, right, for your websites. You can also see if an artifact got signed at a specific time, moment in time. Another aspect of certificates is that these signing certificates only are only valid for 10 minutes once they get created, solely for the purpose to sign your artifacts. And after that, you can still validate it because the signature will remain the same. And when it got signed, the certificate was valid, and after that, you cannot reuse it anymore, right? It's the same with Let's Script. There was a much more shorter cycle. I think it's like 3 months initially, which they had for a TLS certificate. This is even limiting it to 10 minutes, enough for your build server to wrap up the stuff, signing it, and moving it out. The cool thing is that it can also be used to sign artifacts. And the other cool thing is that it can use keyless signing based on artifacts. And it's not completely keyless because you still have a certificate that generates an ephemeral key that you use, but you can use OpenID Connect and have your identity being put inside the signing certificate in order to then sign it. And the nice thing is that I think since November of 2021, GitHub Actions also supports OpenID Connect from a build process, meaning that it can go out to Sigstore with its identity, which is like, hey, this GitHub runner is executing this build, get a certificate and sign it and put it in time. And if you then look back on, let's say this artifact was signed by this runner that was run at that point in time, you can get the whole chain of provenance for your software. That's pretty powerful, right? At least gives you the guarantee that you know that it was built at that point. If there's that library inside that got compromised, that's still no guarantee, as we've seen with SolarWinds, but it helps out having authenticity with your libraries, right? It's a little twisted. But how does it then look? And I want to briefly show you how you can do this signing easily. So let's move back to this. Let me close these files and stop my presentation in order for you to see what I'm doing. So let's do it like this. So what we see here is, these are just the commands I'm going to use. So let's say we have a file, and that has, it's a text file, and we say, hello NDC, and we concatenate that in NDC Sydney.txt. We have that file. What we can then do is we can ask Cosign to sign it. And what I'm going to do right now is based on the OpenID Connect provider. So I'm opening it up. It asks me like, hey, your email address will be associated with the way you're going to sign it. Do you want to continue? And what happens then? It opens a browser. And I can say, okay, I want to sign this artifact, and let's use GitHub. And I think I'm already signed in, or not. No, I'm not. So I'm going to sign in with my password as well. That's the one. Sign in. And then I need to have my phone, which is in my bag, because I have multi-factor authentication installed. Just a second. I thought it was a bright idea to put it away. Not to have it here. But you should practice what you preach, right? Multi-factor authentication. Let me go to my GitHub one and then type in the code. Keep your eyes closed. So what it does right now, it says, hey, Sigstore, I'm not sure if you can see it, but it says it's successfully signed it. If we then go here, we see that it has created a transparency log entry with this identifier. I'm going to copy that one, because right now I'm going to ask the transparency log to give me the information. And these are all the tools you can get from Sigstore itself. So don't be bothered with seeing all of this. And these are all inside the demo scripts I published if you want to rerun it yourself. So I'm going to put the ID here and then get the output. Then we will get a new file, which is in reproducible. Let me also put the NDC Sydney text in Cosign. I should have gotten to the other folder. So what we can then do is we can also get this, let me just grab the certificate. You can get the signature from that. So you can validate this. I've screwed up the file, so I cannot check the signature anymore after this. But let me show you the certificate, because that's exactly what was the key based on this. So what we see here is it here already or not? output.json. I've missed something. Let me grab this one once more. There it is. And then the other one, which is just open SSL command. And we will see it here. Let me maximize this. So this is the certificate that I generated when I did that sign in. Over here you see that there's my identity. That's the thing I used to sign in as well. And over here you see that it has a validity of 10 minutes, right? So 5:33, my machine is still in European time zone. And it finished after here, right? After that you can take the signature and validate it. But as I said, I screwed up the file, so I cannot do it right now. But you can just confirm that that's the file that was created at that point in time. And what we see over here as well is that it has also registered a SHA hash, which is a thumbprint of that file. And you can cross-check it, and that's the same. So that gives you the guarantee that this thing was signed by me, or at least the person that had access to my account at this point in time, right? Giving us some guarantee within our supply chain. So that might be helpful with signing artifacts. Let's move back to the presentation. Funny thing is that with cosign or with Sigstore, there's also Git commit signing based on that. And this is something that was introduced in summer. And it says you can do exactly the same. You can do the Git commit I did before. You will get the browser window, you need to sign in, or you already have an active session, but that can be additional factors as well. So I think that's cool. That gives us more tools to choose from, and you can just choose the things that fits best. The only thing that this one lacks is you cannot get the verified one like the flag inside of GitHub, because they work based on the key that you publish. I believe they are working on also trusting Sigstore certificates and all the stuff that's behind it in order to have the same shield. So I talked about the automotive industry once I started out, and we're going to move back because right now we have seen all the different areas about signing, building. How can we have better hold of our supply chain, and how can we do a better job? And I think there's a really good analogy within the automotive industry, because we have all been in a situation where we have a recall of our call saying the dealership said, hey, there's a part in your car that's faulty that needs to be replaced, right? And this picture shows the same car that you saw on the production line with all parts taken out. And this is a car magazine I read, and they look into it like 100K kilometers. It has driven that. How does it look inside? But how did they do that, right? How are they able to recall the fact, like, hey, this part was in your car? So this is a car supply chain as well of disc brakes that are used on that car that gets manufactured, right? There's a steel factory that produces steel and has iron ore from a specific origin, that hopefully that steel gets tested based on all the checks, on all the standards they need to have. Then that steel will be pushed to the Bosch factory where they create disc brakes out of it. They take that batch of stuff, they produce the disc brakes out of it. They hopefully also test it based on the standards they need to comply with. Then that disc brakes will have a series, like it belongs to this series. And then let's say, for example, it's being used by Ford, Volkswagen, and Renault in order to be put in the car on, you see on the right, that includes all the different parts like the disc brakes, the exhausts from another company, the tires, and that make up the car that's being identified with that vehicle identification number. They have a full ledger of things and know exactly what's inside. And what do we need for software? Similar, right? And that's something you've probably heard about, which is the software bill of materials, or SBOM. And it's an industry standard to describe software about like who created it, what's the project, product itself, how was it created, what materials. This is a pretty wide standard, and it's there are different formats as well. But this is the baseline. And it describes pieces of your software and what's inside. And the first step you could do yourself is to look into a project called CycloneDX. CycloneDX is a lightweight SBOM that allows you to create a dependency graph of your projects. And it can do that for .NET, it can do it for Maven, it can do it for a lot of systems. You'll find it over there. And it also does a transitive one, which is like including all the stuff that's underneath. That's cool. It can then produce an SPDX, which is a component standard that you can then later on consume in another system. So that's also cool. You can get this for free. I'm going to show you an example later on in the last demo on how you can create this. So what else can you do? So with one of the releases done with Docker in April, they also included the ability to create an SBOM out of a Docker container by the CLI, Docker CLI itself, right? So that's hands-on, you can just use it straight away. It's based on a tool called Sift. Shift can also identify layers inside Docker containers. It can see file systems. It understands .NET projects. It understands Java projects. And it can create a bill of material of these are the components that are inside, because that's valuable. As I said, you don't want your components to be vulnerable to something, so you need to check it. And with an SBOM, there are tools that you can also check it against known vulnerabilities. So that's cool. And it gives you a guarantee like, hey, in the organization, hey, we use this library, or this library has been compromised, there's been a breach, which projects do it use it? And then you can hopefully look into the SBOMs and find that. Microsoft also released their SBOM tool, I think a month ago or so. The only thing it lacks is transitive dependencies, at least for .NET, and that's the reason why I'm not using it. And then CycloneDX is better. Hopefully they add it, but this is a tool, if you want to use a Microsoft SBOM tool, look into that one as well. And there's another one, which is in Todo. When I started out talking about this, this is an academia project done by a university in New Jersey, New York, where they have a framework to secure the integrity of software supply chains. And they take it to the next level. It's quite a complex project. And this is a video of my demo I did at NDC 2020. You can find it. I have the YouTube link in the notes, where I look through what you can achieve within Todo. But the power lies in the fact that you describe who is allowed to do what, at what stage in your software supply chain. And you have all those steps signed by public-private keys you saw before. And that allows you to create a ledger, and then at some point, if something is manipulated in between, you're able to detect that. I think this is too complex. That was also my struggle with this demo. I created a one-on-one demo. Is there something that relates to how we write software nowadays? No, it's too complex. The tool had a lot of promise. It did involve some of the standards that you see the other tools use as well, so that's good. But I think it was too complex at that time. So if we look at SBOMs in general, and that kind of things, what else do we need in order to mature our software supply chain? And there is a really cool project called Google SLSA, or Google Supply Chain Levels of Software Artifacts, SLSA as they call it themselves, which is a maturity model that shows if you do software supply chain security, there are these levels that we define and some best practices that they expect you to do. And these levels, I'm hoping that you can read this, there's 1 to 4, and of course 4 is the best, and 1 is to start out. With 2, you have a tamper resistance of the build server. You have an automated, let's say, CI/CD script that runs on a build server. That makes sense. That's a hosted source build, right? So you run it somewhere. And there's signed provenance. And of course, with 3, there's even something that they call non-falsifiable provenance. If I have a developer that uses the CI/CD scripts to alter a build, then the provenance that you generate don't give you the guarantee that that's really the thing that happened, right? Maybe something was compromised. You want to have something that's outside of the build process that signs off for it. And that's what SLSA level 3 introduces. So when they worked on this in April of this year, they produced a level 2 provenance generator for GitHub Actions. And they also showed how level 3 would look if you do Go and Go binaries with the provenance generation done outside of the build, but it gets inputs builds. It's based on GitHub hosted runners. It uses Sigstore underneath the hood, the thing we just did with my browser window. It also does that one under the hood if it builds stuff. And there's a verifier included. And luckily, the end of August, they finally also released the SLSA level 3 for generic projects. And this is cool, because this allows us to use it in .NET. And that's exactly what I did. And that's the last demo I'm going to show you. So I have a GitHub repo that is like my awesome PDF component, which literally does nothing, but it has one dependency that pulls in a lot of stuff. I'm generating a CycloneDX SBOM based on that. It uses Sigstore keyless signing underneath the hood with some of the steps. And there is a SLSA level 3 provenance generating done. And then you can produce SBOM data and consume it. So let me quickly show, I believe I had that website open as well, over here. If you're able to see that. So if we look into, this is the project itself, the link is in the end as well, so don't worry about taking it. This is just an ordinary build, like the default one you get if you do a .NET build in GitHub Actions. Let me increase it a bit more. So what the key is that we still do our own build, but what we want to register is we want to create a SHA-265 hash of our artifacts that we see as our deliverable, right? And in my case, it's a NuGet package. So I do a .NET restore, I run CycloneDX on the project, and I create a JSON file, which I'm going to show you afterwards. And then I'm going to generate hashes of the things that I want the provenance to be generated for, which is, I'm generating it for my package that I'm generating, and also for the SBOM file that I'm generating. Which means that if you then take the SLSA verifier and you grab that package, you can validate against the public record in Sigstore and say, is this package really the one that's being built by Niels at that point in time? And it will say yes or no, depending on what happened. And the SBOM data you see over here, you can question if you want to publish it, right? You can keep it for yourself, but still doing it in this way also allows you to validate it in the same way. You're saying like, yes, this dependency SBOM file was created at that point in time by that build server, which was initiated by a tag that was signed by Niels in that point in time. That's the whole ledger of things, right? So if we then look into the separate thing, which I said you need to have provenance non-falsifiable, there's a reference to another workflow, which is the one of SLSA, which only takes the hashes of the build and then produces the whole provenance. And let me show you those files, because the build run itself will take a bit longer, but I think it's pretty valuable, what we see here. The file itself, let me format the document, and let me close some of this. What's happening here? Close. So let me go up a bit. So there's a lot of information in here, but we see over here, this is the payload of the provenance that action created for me. And there's that hash again of that file. And trust me, a SHA-265 hash of a file that's generated at that point in time will be unique. So that gives us the guarantee, like if this package matches this SHA-265 hash, I'm pretty confident that that's the case. The same counts for that BOM file, the SBOM file I created. And then underneath over here, you see all the stuff that's related to, hey, Niels initiated this. There's a lot of stuff referencing the GitHub environment itself, which is the Git, which is the source that is being used, which is the commit over here that's being built right now. So it puts all these information in, and this payload is being signed by Sigstore as well. So that ticks the box, right? As I said, this is being executed at that point in time, initiated by me. If something bad happened in between, and we have a moment in time that we know that, hey, Niels, 2 days ago, that library that we're using got compromised, and I can go back into my provenance and say like, okay, so from this moment on, we should assume, or this moment backwards, we should assume that our package was compromised. So now we can fix it, right? It gives you visibility of the things that happened, and that's pretty cool. As I said, I also have the BOM here as well, which is the SBOM. As I said, it's pretty easy. You can also install the CLI, .NET CLI of the CycloneDX and do exactly the same. But over here we see, hey, I have iText Sharp included for PDF generation. It shows you all. It includes iText 7 Commons. There's something that's related to crypto, which is Bounty Castle, that's inside as well. So this gives us the full transitive dependency tree. And we sign this, so it belongs to that build that was executed in that point in time. And that's exactly what you want to have. So, looking into where we're at right now, as I said, SBOM data, now what, right? If you have those SBOM data, that provenance that I just showed could give you some insights on, hey, something happened, what do we need to do? The CycloneDX ones, there is a tool called Bomber, and I think that's a really bad name for a tool that checks for vulnerabilities. I would have named it differently, but it can take CycloneDX files and compare it to a public vulnerability registry, and it will show you like, hey, this library is vulnerable or not. So if you periodically check that, you already are one step ahead of the others, as Laura mentioned this morning, and that's a good thing. You can see this library needs to be updated. So that's the thing. What's next with all the SBOM provenance data? I think the industry is still figuring out like what will be the right thing to do. There are a couple of projects and companies started that take that data, SBOM data, and allow you to make decisions on that. And that gets really cool. One sidestep with SLSA level 4, SUSE, which is also a Linux distribution, they published their vision document on how they want to achieve SLSA level 4. It's really good. I think it's good that they share their vision on how they want to achieve it, because it will be the next level, and that's cool, and they're pretty open about this. So this is GitHub Actions, SLSA. What if you use GitLab? I would suggest you look into something called Witness from TestifySec, which is technically almost doing the same as that GitHub Actions I just showed. It does the provenance, it generates it, it signs it with Sigstore. It's all the same boat. That's cool. And if you're running OpenShift, you're probably doing stuff with Tecton. Tecton Chains is also exactly what I've just shown with SLSA and GitHub. It also has the provenance and it signs it, and it keeps it like in the same ledger, and you can like have a whole chain of where stuff comes from. Getting back to, with 10 minutes left, I'm going to talk about SolarWinds again. So SolarWinds at Cloud Native Security Con, or Cloud Security Native Con, I don't know the exact name of it, but during KubeCon they have a cloud security track, and they published their project called Project Trebuchet, where they showed how they fixed their problem, which they got initially with their supply chain hacked, right? The build server they created looks something like this, and they rely a lot on Tecton Pipeline and Tecton Chains. So they create that provenance steps saying like, hey, this is the source files, this is being built, it's being initiated by this developer. That's all being stored inside a document database or a database. And there's a key management system next to it that's responsible for this. And then at the end, they produce a, let's say, package that will be published to S3 bucket or to the ECR if it's a Docker container that they want to publish. How did they fix their problem? So this is something that's available for every developer, because I'm also a strong believer that security should help out developer making the right decisions and not necessarily getting into the way. Same as like I'm enthusiastic with new technology, so I want everybody to use it in the safest way possible. So what they've done is they give this to the people who develop it, and what they did next to it is they created a mirrored build environment, which is more controlled by the security people who are responsible. But what they do is once a build gets built on the first pipeline, they rerun it in the second pipeline, which is more controlled. And that gives them hopefully the same provenance than the first one did. And if there is a difference between those two, then they have a strong indication that their software supply chain got compromised, right? And keep in mind with SolarWinds, why would they hack SolarWinds? SolarWinds is monitoring software that gets installed on all machines within companies, right? So you can already imagine like why would somebody would love to have access to those systems, because you can get in far away if it's installed on literally every machine, right? But I think this is cool that they published this. They should have published the project. I haven't seen it yet, but as I said, this is SLSA, GitHub Actions, Witness, GitLab, or Tecton Chains. This is that thing. They only took it to the next level by having that validation chain next to it. That's cool. If you're doing Google Cloud stuff, then when I started out talking about it, Google has released 2 components in 2019 called Grapheus and Cretus. And Grapheus is their provenance database that you can store data into, that's like SBOM data, provenance that's being generated. And Cretus is their binary authorization on their platform, allowing you to take decisions like, do you want to deploy this or not? Let's say I only want to deploy signed images. That can be a condition, and that's cool. If we then look at what you can do in Azure, there's only one spot where it could fit in, which is Azure Policy, but I haven't seen anything of Microsoft doing similar things. There's a company called ChainGuard, which is being started by people from Google, Red Hat. They're also involved with SLSA, with Sigstore, and they are doing something which allows you to ingest SBOM data and then have a Kubernetes cluster conditionally deploy stuff or not based on that data, right? That's the next level. That's cool, and companies are being created around it. So I'm definitely keeping an eye out like what they're doing. But I think that's the stage where the industry currently is at. So to wrap up with 6 minutes left, if you look at supply chain problems in general, my conclusion hasn't changed over the last 2 years that I'm talking about this, because it's not like how, but it's more a matter of when stuff happens. And then you should be aware of what's inside your software supply chain, right? All the stuff we mentioned about libraries, about FBOMs, and know what you have pulled into your project, right? What are you using, for what reason? And then I am a security guy, so I would love you, like as Laura also wrapped up, like security needs to be integrated into your development lifecycle from the start. And I would encourage you to look into the SBOM stuff, Cyclone DX, for example, and see if SLSA might also be a possible path for you to going forward. And try then to work with that SBOM data and work your way out of that. So, with 5 minutes for questions, the GitHub repo I mentioned is NDC 2022. In my GitHub repo you see my 2 talks and you can click through. You can reach me on my email or on my Twitter handle. I'm going to be around, of course, for the rest of the conference. So I know it was a lot. It was a lot for a last session. I'm happy you stuck around with me. So yeah, if there's any question, we can do that right now. In the back, you get a microphone. Yes.
As you mentioned, one of the things that's kind of like the scariest about this area at the moment is like using all of these. We've got all these third-party dependencies that we're using in our application.
Yeah.
And so one of the things we're looking at the moment is we've got some requirements around SOC and being audited and having to have processes in place for auditing the third-party applications that we use.
Yeah.
Do you have any recommendations on how can we possibly actually audit all of these dependencies that we're using and have some confidence that they are actually secure, given that there's so many of them and they have so many nested dependencies in themselves?
Yeah. I don't know like the exact like standards and what you need to comply to, but if you look at, like first step would be to at least have SBOMs of those projects to know what's inside, right? Maybe you have centralized repositories for your own components that allows you to have visibility on what's used where and when. That will be step one. And in order to make sure that you have no vulnerable ones, that's something you need to like periodically check if there is a, and it also depends a bit on like how big the risk model is in general, right? I always get the question as well, like, hey, if I have a vulnerable library, do I need to update it straight away, or can I wait for it for my next release because it's going to interfere with a lot of work that we're doing, right? That's also a thing that solely depends on the risks that you're taking as an organization or as a company, right, and are willing to take, because maybe you're using that library in such a way that it's not necessarily a problem. That's something you need to cut off. So you need to have, and I'm hoping I'm answering your question, you need to have visibility and periodically check what's inside. I think that's the best to do. And what type of standards you need to comply with, that's one I need to look up if you really want the answer. So, but good question, thank you. 3 minutes left, so still, otherwise, I'm going to wrap up. I'm going to be around, as I said. Hopefully you enjoy the rest of the conference. See you around, and tomorrow, 3 p.m., I'm going to continue about .NET assemblies and sandboxing those. I hope I can see you there, and otherwise, enjoy the evening. Thanks.